Hi, this video is a continuation of colligative properties of solutions. The last video was about the vapor pressure and how the vapor pressure of solutions was lowered with the addition of a solute to a solvent. And this video is going to look at boiling points and freezing points and how a solute affects these properties. So first of all, let's define a boiling point. The definition of a boiling point is when the vapor pressure, and now we know what that is, equals the external pressure acting on the surface of the liquid. And so that's the definition with words, but pictures always seem to help me. And so here's a picture of what they're talking about. So we know we have atmospheric pressure pushing down on this liquid here. And when our vapor pressure of our liquid is equal to that pressure pushing down on the liquid, when they're equal, that is then the boiling point. Now over here we see that this boiling point is 65 degrees Celsius, and they're both at the same atmospheric pressure. So that must mean, because this boiling point is higher, that that must mean that the intermolecular forces in this liquid were stronger. It took more energy to separate those liquid particles from themselves and to turn into a gas. So now let's go ahead and look at what a solute does to the boiling point of a solution. So again, we're going to look at a little animation. Let's use water. We know that water should boil at 100 degrees when there's nothing in it, 100 degrees Celsius. Let's use 200 grams of water and let's add some sodium chloride to it. And so the sodium chloride, let's add, oh goodness, let's add, 10 grams. Okay, now we know, I'm going to dump it in so we see it up here. We know that sodium chloride, when you put it in water, is going to separate into the sodium ion and into the chloride ion. And so we've got these sodium ions, these chloride ions now in this solution. Our boiling point normally is 100 degrees Celsius, and we're going to talk about what these KBs and KFs are. But what is going on here is, see these orange particles? Those are our solute particles, the sodium ions or the chloride ions, and they're just they're not evaporating like our solvent molecules are. All right, our boiling point with the sodium chloride in the water is 100.84, 100.85. So what does that mean? That means that a solute has increased the boiling point of our solution. So boiling points increase with the presence of a solute. So here we go. Let's go ahead and fill this in. So we saw that the vapor pressure decreased, but the boiling points will increase. Now, the more solute particles that we have in there will increase the boiling point. So if we put even more salt in there, it would go up even more. Now, also, atmospheric pressure. Okay, remember, boiling point is when our vapor pressure equals atmospheric pressure. So if atmospheric pressure increases, then the boiling point will also increase. All right, so that's boiling points. Now let's have a look when we talked about the number of solute particles. Here we've got different solutions. We've got a molecular compound, we've got sodium sulfate, ionic, and sodium chloride. They're all the same concentration, and they would like to know which one will have the highest boiling point. Well, this will not separate into its molecular, it will not ionize. Sodium sulfate, it will actually separate into how many ions? So 2 sodiums and 1 sulfate, so it's going to separate into 3 particles. And the sodium chloride is going to separate into 2 particles, the sodium ion and the chloride ion. The sodium sulfate would be 2 sodiums and 1 sulfate. Do not take apart these polyatomic ions. They're not going to break up. We're going to have sodium ions and we're going to have sulfate ions. So which one do you think would have the highest boiling point? Well, they're all the same concentration. The one that has the most particles, though, would be B. It would have the highest boiling point because it has the most particles in solution. All right, now here's something where we have all the same number of we have this, we have the same exact thing, sodium chloride. So this will split into two particles, but we have different concentrations. Which one will have the highest boiling point? Well, the one with the highest concentration, because it's going to separate into two particles. And so the one with the highest concentration is going to be the one with the highest boiling point. And now here we've got everything all mixed up. We've got different concentrations and we have different things. And so this can be a little bit tricky. So here the number of particles is 2 particles, the sodium and the chloride, and then I just kind of multiply it by the concentration, and that gives me 0.5. This is molecular, it's not going to separate, and so it's going to just be 0.45. And the calcium chloride is going to separate into 3 particles, 1 calcium and 2 chlorides. And so the one that has the biggest number here, because we are changing concentrations and they all have a different number of particles, the one with the highest number, the calcium chloride solution, that is going to be the one with the highest boiling point. Alrighty, so how much? Let's talk about it quantitatively. How much will a solute raise the boiling point? Well, as you well know, there's an equation for that because, well, it's chemistry. And this equation is given to you. You do not have to have it memorized. And it looks like this. The change in the temperature of boiling, so how much the boiling point goes up, is equal to I, Kb, little m. All right. We need to define all of this. All right, the I is called the Van Hoff factor, and it is just the number of particles. So on that last slide, when I was talking about calcium chloride, the I for that was 3. Sodium chloride, the I for that is 2. Anything that is molecular, or they might just say that it's a non-electrolyte, which means it hasn't separated into particles. The I for that is just 1. Okay, that's what the I is. Kb, this is a constant, and you will always be given the Kb value, and it depends on the solvent. So you'll be given a list of solvents and their Kb values. And now we have to talk about little m. Little m is called molality, and that is defined as moles of solute divided by kilograms of solvent. Now, this is solvent. Now, the question is, why do we need another concentration unit? Well, this is a special concentration unit because moles will not change with the temperature and neither will kilograms. So this is a concentration unit that remains unaffected by changes in temperature. And as we see here, we're going to be changing temperatures. So molality is something new to us. It is moles of solute per kilogram of solvent. And now all we have to do is multiply these 3 things together, and that is how much our boiling point will be elevated. All right, so here is an example of Kb values. Again, you don't have to have these memorized. They'll always be given to you. And so you can see they're very unique for different solvents. All right, so let's just do a problem. Let's calculate the boiling point when we put 8.5 grams of C12H22O11 in 100 grams of water. All right, so the first thing is let's get our equation written down here. And that would be the boiling point elevation is equal to I Kb m. Well, I for this is 1. Kb, when we look at the table, for water, the Kb for water is 0.51 degrees C per molal, and then we need to calculate the molality. All right, we need moles of our solute. Our solute is our C12H22O11. A mole of that is 342.34. grams per mole. So our moles of our solute is 0.0248. And we need to divide that by kilograms of our solvent. 100 grams to kilograms is 0.1 kilograms. And so our molality is 0.248 molal. All right, we've got all of our numbers. I is 1, Kb is 0.51, and molality is 0.248. How much will our boiling point be elevated? It will be elevated by... Here we go. When you multiply them all together, you get 0.127, and that is degrees Celsius. All right, now the question didn't ask how much the boiling point changes. The question asked us to calculate the boiling point. Well, the normal boiling point for water at 1 atmosphere of pressure is 100 degrees Celsius. And you don't need to know the boiling points for all the solvents. They'd be given to you. But you do need to know that we need to add this because our boiling point went up by that much. And so our new boiling point is 100 and to 2 significant figures, or we'll go to 2 decimal places, 0.13 degrees Celsius. Okay, so our boiling point did go up with the addition of that molecular solute. Okay, so we have now talked about vapor pressure and we've talked about boiling points. The next video will talk about freezing points.